Now we're going to learn how to name compounds in what is known as nomenclature. First, we're going to name ionic compounds, and then second, we're going to name molecular compounds, and third, we're going to name acids. Acids are something that we haven't heard before, but we should just have a general idea of how to name them. So for ionic compounds, the first thing, of course, you want to always identify that it is an ionic compound. And what is an ionic compound? It is made up of a metal and a non-metal. Once you've identified that, then you want to ask yourself, is the metal in there, does it form only one type of ion? Or is it possible that it can form more than one type of ion? And then you want to go from there how to name it. So let's see that. Okay, so those are the metals whose charge is invariant from one compound to the other. Okay, so that means there's no other possibility, there's no ambiguity. Lithium will always have a positive 1 charge, and it's because it's in group 1A. Remember how we talked about we can predict the charge based on the position on the periodic table. So magnesium will always have a positive 2 charge because it's in group 2A. Aluminum will always have a positive 3 charge because it's in group 3A. Those are the ones that we can predict based on the position, and they are for sure always that charge. In addition to that, we have zinc and silver, and you just have to remember that zinc will always have a positive 2 charge and silver will always have a positive 1 charge. Now, the metals that can form more than one type of ion are usually the transition metals. So chromium can be positive 2 or positive 3. Iron, also positive 2 or positive 3. The copper combination can either be positive 1 or positive 2. Tin can be 2 or 4. And these are all for reasons that are beyond this course. But you just have to know that these metals form more than one type of ion. Okay, so let's talk about naming the binary ionic compound containing a metal that forms one type of cation. Okay, so usually you just give the name of the metal, cation, as it is directly from the periodic table. You put a space, and then you put the base name of the anion, but instead you add "ide." Okay, so since the charge of the cation will always be the same, we don't have to mention it in the name. So for MgO, we write the name of our cation, magnesium, and then we put a space, and we put the base name of our anion, which is ox for oxygen, and then we just put the IDE ending. And so it becomes magnesium oxide. We don't have to mention the charge here because magnesium is always going to be positive 2 charge anyway. Same thing with NaCl. We write our name of sodium, space, and we put the base name for chlorine and add the "ide" ending to it. So it becomes sodium chloride. Okay, you go ahead and you give this a try and then replay the video to see if you got the correct answer. So magnesium here forms one type of cation, which means that we just write it like so, magnesium, and then fluoride is our base name of our anion plus the "ide" ending. Potassium is also ionic. It's got a metal and a non-metal. So in the metal here, the potassium only forms one type of cation, so it's just potassium bromide. The zinc here, remember, is one of those that only forms one type of cation, zinc plus 2, the one that you just had to know. And so it's zinc, and this time we have nitrogen, so we're going to call it nitride with the IDE ending. Okay, now we want to talk about naming binary ionic compounds containing a metal that forms more than one type of cation. And just don't forget what I mean by binary is that there's a metal and there's a non-metal, okay? So this time we're forming more than one cation. So since there's ambiguity in the charge of our cation, we have to state our charge after we name our cation. So we name our metal, we put in parentheses right after its charge in Roman numerals, and then we put the base name of the anion plus the "ide" ending. So in this case, we got iron and we have chlorine. Well, which charge would this be? Would iron be the +2 or the +3 cation? Well, we can deduct this from the chlorine. We know that chlorine is always a -1 charge, and there's 3 chlorines. So we know that our anion has got a -3 charge. Well, here we have 1 iron, so it looks like it has to be a +3 charge in order to cancel out our -3 right here. So we know that it's iron +3. So when we name it, we say iron, and then we put in parentheses a 3 in Roman numerals, space, followed by the base name of our anion plus the "ide" ending. And so we call it iron 3 chloride. If we just call it iron chloride, that would be just confusing, because then is it FeCl? Is it FeCl2? We just don't know. So this is wrong here. That's why we want to make sure to put the charge here to avoid any ambiguity. Okay. Another example is when we have the chromium and the oxygen here. Well, let's figure out what the charge on our chromium is. Well, we know that the oxygen is always a -2 charge. There's 1 oxygen and 1 chromium, so this must be a +2 in order to balance our cation and anion. So it's chromium +2. So we write chromium in parentheses 2 in Roman numerals, space, followed by oxide. So it's chromium 2 oxide. Okay, now you go ahead and you give this a try and replay the video to see if you got the correct answer. Here we're dealing with lead chloride. So let's tell ourselves it's an ionic compound. It's got a metal, non-metal combination, right? The metal here forms more than one type of cation, so we have to state its charge in the name. So how do we figure out its charge here? Well, the chlorine is always -1, so our anion is -4 here. So our cation, we only have 1, so it must be +4. So it must be lead +4 in order to cancel our charge out. So we write it as lead 4 chloride. Okay, now for B, again, we identify that it's a lead cation, and it can form more than one type. So let's figure out its charge. Our oxygen is -2. That means that this must be +2. So it becomes lead 2 oxide this time. Okay, so let's talk about some of the polyatomic ions. What do we do when it's no longer a binary compound? Well, just remember that we have to memorize our polyatomic ions so we learn to recognize them as a group. Okay, and a thing to know that you will always have, for example, when we have the nitrate and the nitrite, the 8 ending always goes to the one with the more oxygens in it, and the ite ending always goes to the one with the less oxygens in it, like sulfate and sulfite. Sulfate, because it has the 8 ending, will go to the 4 oxygens, and sulfite will go to the 3 oxygens here. In the case of when you have more than one combination, like for chloride and chlorate, chloride goes to the one with the less oxygen, chlorate goes to the one with the more oxygen. But let's say you have one more oxygen than that. When you have 4 oxygens, you add the perchlorate ending. So it's chlorate plus 1 oxygen. But if you had one less oxygen than the chloride, then you say hypochlorite. Hypo meaning less than, one less than chloride. So you have 1 oxygen less. This is just to help you memorize some things. Otherwise, you have to memorize this whole table. Okay, so let's see how we name when we have polyatomic ions. We follow the same rules, except now our anion becomes our polyatomic ion. So if we have potassium, we identify it's an ionic compound because it's got the metal, non-metal combination. And potassium is one that forms only one type of cation. So I can just write it without having to write the charge after that. Now I know I learned to recognize that NO3 is nitrate, so it becomes potassium nitrate. Very simple. Okay? Now B is an ionic compound. It's got a metal and a non-metal, right? But it's got iron in it. And iron can form more than one type of cation. So let's figure out its charge. Well, the hydroxide ion has got a -1 charge. So our total 2 times -1 is -2, which means this must be +2. So it becomes iron 2 hydroxide. Okay? Now here we have 2 polyatomic ions, our ammonium ion here and our nitrate. And this is +1 and this is -1. So we just call it ammonium nitrate, because ammonium will always have the +1 charge. Okay, now you go ahead and you give this try naming ionic compounds with polyatomic ions. So we have potassium. Potassium only forms one type of cation, so it's going to be very simply potassium. We don't have to put the charge after that. And we learned to recognize that this guy is called chromate. So it becomes potassium chromate. Okay. B, we have manganese and we have nitrate here. Manganese is not listed, I believe, but on your table. But here we can easily figure out its charge, right? Because we have nitrate as -1. So -1 times 2 means that we have a -2 anion charge, which means that this must be +2 in order to balance out. So it's manganese +2. So we write manganese. Don't confuse Mn for magnesium. It's manganese. It's a transition metal. So manganese 2 nitrate.